Okay, so this is lesson 9-1, and actually I'm going to back up even further. We're starting a new chapter. Okay, it's on freeze. Thank you for letting me know. All right, so there we go. Let me move my desk off here. Okay, so we're starting a new chapter, so I've always said, and I've said this on all my classes, if I could choose a language to learn, it would be Spanish. I think it's the most beautiful language spoken. Yeah, I love music so much. And Spanish to me sounds like music because it has rise and falls and the ways they speak and enunciate. And it has the fluidity of the rolling of the R's and the N's and just all the way that they pronounce. It's just a beautiful language. And it has rhythm too. If you listen, a lot of the words are some are staccato, some are, drawn out, and I love it. I love Spanish. So the great thing is that in the school we have a lot of students that are bilingual, that their second language is Spanish. So this textbook has excellent Spanish resources. So last year about this time, I started bringing in Spanish language into the lessons and showed not only the terminologies, that once in a while we'll watch a Spanish math video and see that math is truly a universal language. And I learn from listening to it and watching, and I pick up on certain terms. So these are all the terms throughout the chapter that we'll be using. So we're all going to say it together in English, and then we're going to say it in Spanish. And I'm going to apologize in advance because I can't roll my R's, maybe a TD, and I don't know all the pronunciations. So I'll be kind, and you guys be kind to me, and I apologize in advance if I butcher any of the words. But just correct me, and maybe eventually I'll pick it up. But I can't imagine what it's like for students who or anybody who comes into this country and they've never heard English. And I can't even imagine what English would sound like to somebody for the first time. I think it would be like frightful. It's like, what is this language? To us, we're raised speaking it, so we don't know anything different. But it's like us listening to German or to listening to a British person talk with that beautiful accent. I could listen to British people talk all day long. Or Ireland people with their Ireland accent. I just love the dialects. I love the languages. But I can't imagine how hard it is to learn an English language because there's so much of a mixture of all the languages put into it. And one word or one sound can have several different meanings, like two. You can be T-O-O, T-O, T-W-O, what is it? But anyway, so let's pronounce these in English and then let's pronounce them in Spanish, okay? So the first word is arithmetic sequence. So say arithmetic sequence. Good. And now, here we go with Spanish. The same word in Spanish is progresión aritmética. Progresión aritmética. So say it. Thank you. All right, now arithmetic series. And I think it's serie aritmética. Say? Okay, is that correct? Does anybody know? Is series Siri? Syria? Celia? Seria? Okay, I'm trying. Sorry. Seria aritmética. Okay, next, common difference. And in Spanish, diferencia común. I think. Is it común? 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 Común. Okay. Diferencia común. Okay, next, common ratio. And the Spanish is razón común. Is that right? Is that right? Close. Okay, next word. The next two words are alike in English, and they're alike in Spanish with one slight difference. So pay attention to that too. Converge and converge. Here is the G is an H, right? So convergir.
It's a J.
J, convergir. The G sounds like H, right? Or
Yeah.
like here.
Yeah.
Convergir. Okay, so say convergir. And the next word is diverge. And then divergir. Okay. Next, come on, I need to hear everybody. Explicit formula. And the Spanish is formula explicita. And correct me if I'm wrong, guys. Okay. Geometric sequence. And then progresión geométrica. And so notice that in English they do explicit formula, geometric sequence. But when you do the Spanish, it's reversed. It's formula explicita and progresión geométrica. So they use progresión for sequence and geométrica for geometric. Okay, then we've got geometric series. So, and then, oh, that was the word I can't pronounce. How do you say it again? Serie geometrica. Say it again. Thank you. Okay, and now here's one that I think I butchered too. It's limits in English, so say limits. And is it limitus? Limitus. Come on, guys, everybody. Thank you. And then the last term, recursive formula. And then formula recursiva. Okay, give yourselves a hand. Yay, good job, guys. So, there we go. And will you recognize these when you see them in a video? And know that I'll be playing the English and the Spanish videos. So, we will be doing a little of both. And if I had more languages, I'd be doing more languages. But that's the one that the book came with. All right, so that's going to take us into the opening. So if you looked, let me back up one more time. The whole chapter is about sequences and series, and you heard that over and over in these words. Okay, so sequence and series, that's what this whole chapter is about. And it's a short chapter of 5 lessons, so it will end very quickly. The first lesson is about mathematical patterns. And those of you who remember back in elementary days that you were counting and looking at little pictures and trying to figure out what's happening from this picture to that picture. Well, we're back at it. This is what we're going to be doing. So if you notice that this first activity I give you, it says for each figure, how is the number on the center tile related to the numbers on the other tiles? What will be the center number in figure 6? How about figure 10? What about figure N? And that's the thing that we're going to focus on today is what is it when it's an N? Well, how do we do that? And explain your reasoning. So take a minute and look at these pictures and let's focus on the first question. That's an elephant. That had a lot of questions in it. So we're going to eat the elephant one bite at a time. So the first question was how is the number on the center tile related to the numbers on these other tiles in each figure? So, for example, how does number 4 relate to the tiles around it? How does number 12 relate to the tiles around it? 24 to these, and 40 to these. So look at this for just a few seconds and then turn and talk to a neighbor and discuss what you think it is. Okay? What do we think? I heard a lot of good conversation. I love this class because you guys always do such good work. Not that I don't love my others, but you guys really work hard, especially when I ask you to do something group-wise. You always do a good job. So what do you think here? What's going on with that center number and the tiles around it? What can you say? Yes, all of the outside numbers, all the numbers in yellow of each figure add up to be the green. So now let me really challenge you here. So let me explain. Oh, sorry, I didn't hear. Sorry. Thank you. And you need to get your things out and put your backpack up. Okay, so I'm going to freeze this for a second and take attendance. I forgot to take attendance. And I want you to think of how could you represent this mathematically? How could you represent this mathematically? So now I'm going to pause the video. I'm going to do attendance, and then we'll come back. So discuss that now. Okay, so I hear it's starting to die down. Anybody have any ideas? And don't forget that you've got your whiteboards today, so you can, this is when the whiteboards are going to be really helpful, is when you sit down and you look at how can I represent this? So we said that each figure, so for figure 1, let's just say in all of these figures, I'm just going to call this whole group A. So this, I'm going to let this be the first element of my A group. There's A sub 1, A sub 2, A sub 3, A sub 4. So that's how we're going to represent all these. And these are all A's, not 9's. Okay? So I'm going to represent them. So what can I say about A sub 1? We could say that that first element is equal to, and we'll let the center figure be the element. It's going to be equal to what? Well, if this is my first element, I have 1. Well, I've got 4 1s, right? So it's going to be 4 times 1. How about the next element? For element 2, it's going to be 2 plus 1 times 4. Plus 1, sorry. Actually, let me rewrite that because I want to be the same on all these. So it's going to be equal to 4 because we have 4 of these legs that are all the same. 4 times 2 plus 1. And for the third figure, what can we say? 2 plus 1. So whatever the sum is, and this one would be A sub 4 equal, and this is just my representation, and I'm not saying it's right or wrong, it's just how do you interpret this? And I want to hear what some of you did. So 4 times 4 plus 3 plus 2 plus 1. Okay? So if I ask you, well, what is the center number in figure 6? So we know, excuse me, if for figure 6, it would be equal to what? 4 times 6 plus 5 plus 4 plus 3 plus 2 plus 1. And then on your whiteboards, why don't you calculate real quick, what would the 10th element be? And get it down to a single number. So that would be 11, 15, 18, 20. So this would be 4 times 21, which would be 84. Yeah, hang on just a minute. No. You're already done? Okay, let me see your board. What's the final number? Okay. Wow, okay. So when I'll give you just another minute and then okay. And then what would your final answer be when you do that math? Okay, good, 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 good. I'm loving what I see. Good, good. And then what would that final answer be, Brittany? Good, 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 good. I love what I see. I'm seeing over and over, this is the final, good, yes. This is our final answer, 220. And I love to see the way some of you work this out, because some of you did it very intricately, and some of you are just like, 19, and so on, 19 plus 8, 20, so on and so forth. I see that. And then I see some of you just put it on a calculator and wrote, what was it, 55? At the end, it was 55. I saw some of you do that. And then 55 times 4 is 220. So lots of different ways to get this. Now, what we're going to focus on, before I move on, does anyone have any questions about this? So this is a pattern because we figured out a way that we can go further way down the line. You can just give us a number and we can calculate what that is without seeing all the things in between. For example, we had the first 4 figures, but without the 5th figure, we could tell you what the 6th figure is going to be, and we could tell you what the 10th figure was going to be. We could even calculate what the 20th figure is going to be, but it's going to take a few minutes, right? And we get very tedious. But what we're going to learn today is how to recognize patterns and how to create mathematical expressions to help us calculate things down the line. And when we talk about down the line, we're talking about something called a series, okay? Or excuse me, a sequence. Whoops, series is coming up. Today is sequence. All right, so a sequence is an ordered list of numbers. Okay, right there, an ordered list of numbers. And then each item in this sequence is called a term of the sequence. Okay? So, a sequence is an ordered list of numbers. A term, each number in the sequence is a term of the sequence. So, we'll talk about, let me back up to this thing. This whole sequence right here, well, this A1 is my first term in the sequence, second term, third term, fourth term. And I use the A sub 1, A sub 2, A sub 3, and A sub 4 purposely because this is how we represent a sequence. With A sub 1. And each of those sub numbers, A1, A sub 2, 3, A sub 4, those are our terms and the term number. So A sub 1 is the first term in the sequence. A sub 2 is the second term in the sequence. Right here. A sub 3 is the third term in the sequence. So if I ask you, what is A sub 3 here, you would have said, oh, figure 3. Okay? And what does it equal? 24. Okay. So this is how we're going to represent a sequence. Now, there's another way when we start talking about algebra and putting in variables. I just got the 20th element of the first problem. What was it, 840? Thank you. Oh, that was cute. All right. So, your mind is much sharper than mine today. So now we have the first term, second term, third term as get a pencil, a sub 1, a sub 2, a sub 3. Now what if we take away the 1, 2, 3 and we just represent them with n's? So what about if I just say, well, I'm going to just represent this with a sub n, and I'm going to let n equal 2. So ignore all this stuff right here. Just look here, okay? So if n is equal to 2, that means I'm here, right? So if now with my n variable, if I want to express the term before it, I'm going to do what? A sub n minus 1, right? So if n is still equal to 2, it's going to be 2 minus 1, or our first element. And if I want to go to the element right after it, what am I going to do? A sub n plus 1. Yeah. And if I want to go to the next element, it's going to be a sub n plus 2. See? So we can represent terms, terms in the series. Sequence, I'm going to do this the whole lesson. Okay, sequence, sequence, sequence. Term of a sequence. So I can represent all of these terms in a sequence with n's and with variables, okay? Series is coming up. So this is just sequence. All right, any questions on how to represent terms in a sequence? All right. So when you have an n representing the terms in a sequence, we call that an explicit formula, okay? So if I say a sub n is equal to 2n, so I know that my first element is going to be what? A sub 1 equals 2 times 1, n equal 1, right? And the second term is going to be a sub 2 equals 2 times, and what is n? N now is 2, so 2. So for my first element, 2 times 1 is 2, there it is. And my second element, 2 times 2 is 4, there it is. So now when my n is equal to 3 for my third element, my third term, then a sub 3 is equal to 2 times 3, which is 6. And for the fourth element, our fourth element, a sub 4 is equal to 2 times 4, which is 8. So do you see, this is how you work an explicit formula. And if I ask you for the fifth term, what would you write? So write that on your boards real quick and show me. Did your pen die? Oh. Good. Good, 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 good. Good, good. Yes, yes. 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 Isaac, is that dead? Oh, I'll take it. Let's grab another. Oh yeah, these don't last long at all. Yes. Yes, 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 yes. You're good, you're good. Good. Alyssa, good. Yes. Good. Yes, yes. Everybody's getting it. I love this. And this is why I love my whiteboards, because even when you're so quiet, I'm not sure if you're getting stuff or if you're just totally bored. Am I going fast? Am I going too slow? Good. So a sub 5, everybody got it right. So for the fifth element, we knew that it's going to be a sub 5 is equal to 2 times 5, which is equal to 10. Okay? So this is called an explicit formula because we're using n to describe the term of our sequence using the number n. letter, but they say number 2, right? So, any questions on that one? I think everybody got it, so good job. All right, so let's look at this one. Now, for our first problem, it's going to go with problem set on 9-1. 1, 2, oh wait, I'm on the road. 1, I don't see 2. Oh, there it is. 2, 3, and 5. So mark out number 4. You're not going to do number 4 with these. Just do 1, 2, 3, and 5. So let's work this one, then I'll work number 1 with you, and then we'll move on. A sequence has an explicit formula, a sub n equals 3n minus 2. So it's just slightly a little bit, we turned up the notch 1 on the difficulty level from the one we just did. So now we know this is an explicit formula. You will have one of these on your test, okay? So we have to know how to do them, especially to move on in this chapter. So a sequence has an explicit formula, a sub n equals 3n minus 2. What are the first 10 terms of the sequence? So I think you guys have this, right? So now for the first term, you're going to plug in a sub 1. That means my first term in the sequence is 3 times 1 minus 2, which was 3 minus 2, which is equal to 1. So there it is. And now for the second term in my sequence, I'm not saying series anymore, yay. So now for 2, it's going to be 3 times 2 minus 2, which is 6 minus 2, which equals 4. So again, just like in the past when we were using y equals something or f of x equals something, this isn't something that goes into the equation. It's basically like a label. So when we do the a sub 1 equals, a sub 2 equals, those aren't things we calculate with. They're things to let us know what item in this list am I talking about. The first element, the second element. Now let's do the third element. What is it going to be? So 7, very good. So yes, it's 3, a sub 3 equals 3 times 3 minus 2, which is 9 minus 2, which is equal to 7. Okay, and I won't do the rest of this. So there's 4, 5, 6, 7, 8, 9, 10. So they ask us for the first 10 items, and there it is. So just notice whatever n is, that's the element that you're on in the sequence. So if they ask you for the sequence, you would do, well, there's the first sequence, 1, 4, 7, 10, 13, 16, 19, 22, 25, 28. Those are all the numbers in that sequence, okay? So that's not what they're asking us right now. They just ask us to give, what are the first 10 terms? So actually it was what they were asking us. But we have to do a table right now to show that, okay? And if it's really simple, you don't have to do a table. You know, I'll leave it up to you. On a test, you're just looking at 4 answer choices, right? It may be a table, it might not. It would probably be a list of numbers. But this is how you work them. Are there any questions on this? I think I've gone a little overboard on it.
What if there's one with square? Like,
Say that one more time.
what if there's one with a square root?
A square root, you won't have any with the square root. But if it was, if you had a sub n equals 5 minus the square root of n.
Oh, no, I mean power, sorry.
Oh, like n squared, 5 minus n squared. Well, then you would just say, okay, for the first element, it's going to be a sub 1 equals 5 minus 1 squared. 1 squared is 1, 5 minus 1 is 4. So you just go ahead and work it. So it's a good question. Go ahead and work it, and you might end up with a negative number sometimes. It's okay. But for these, you're talking about items in a list. So you'll never have a 0 because you're never going to have it empty list, and you're never going to have anything less than 0 because you can't have negative items, right? So it's always your ends is always going to start with 1. What is the first item in the list? What is the second item? All right, so your ends are always going to start with 1 and move up. Okay, so whatever that equation is on the other side, you just have to work it. If it's whatever math is over there, you've got to insert your n and just solve it. Okay. Let's look at problem 1 on our homework, and let's do this first one together. So on the first one, it says a sub n equal 4n minus 1. And it says find the first 5 terms of each sequence. So they want a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So when we have this, it's going to be 4, for a sub 1, it's going to be 4 times 1 minus 1, which is what? 3. Very good. And for the second term, we're going to have 4 times 2 minus 1, which is 7. And then for the third term, we're going to have 4 times 3 minus 1, which is 11. It's 12 minus 1, 11. And then for the fourth term, 4 times 4 minus 1, which is 16 minus 1, which is 15. And then for the fifth term, we're going to have 4 times 5 minus 1, which is 20 minus 1. Okay, so that's how you do these. Now, they gave you the first 2, 3, and 7, and then they gave you boxes for the last 3. So in those last 3 boxes, put 11, 15, 19. Okay? Any questions on that one? Okay, let's look at the next problem. Number 2 in our homework. And you've got a sub n equals n squared. Oh, there's that power, your question. N squared plus 4. Oh, and guys, we're not going to do 3 and 5 in class. You'll do that at home. But on number 3, there's an error. It should say a sub n equals 1/2 n plus 2. They left this n off, so pencil that in on number 3. Okay? Everybody got that? All right, so now let's look at number 2. And they want the first 5 elements. So let's just go ahead and do it. So I'll let you guys just work it on your own and share your answers with the neighbors when you're done and see if you're correct, not correct. And I'll do it up here, but don't look at my answers, only at the end if you want to check against mine, okay? So go now. Okay, so here's what I got. I heard some conversation, so hopefully you're good. The first term should be 5, the second term should be 8, the third term should be 13, the fourth term should be 20, and the fifth term should be 29. So if you didn't get that on tonight, you need to go home and recalculate and see where you went wrong, okay? And get these answers. Then work number 3 and number 5, okay? And let's move on. Oh, we've got just a couple minutes. All right. Now we're going to talk about something called a recursive definition, and this takes a little more effort and a little more concentration, so make sure you listen here. A recursive definition, it says, sometimes you can see a pattern in a sequence by comparing each term to the one that came before it. So you're going to look at the current term and try to figure it out by looking at what came before. For example, in this sequence, 133, 130, 127, 124, each term after the very first term of 133 is equal to 3 less than the previous. So to get this term, you have to look at the previous term. So to get this, you have to look there. What is it? 127 minus 3. So 127 minus 3 is 124. To get the next term, I have to look at the previous term, 124 minus 3, which would be 121. This is called recursion. And you can't get anywhere in recursion if you don't have the first term. You have to have a starting point. So there's 2 things you need in recursion, in a recursive definition. Let me be formal. In a recursive definition, we must have the first term, a sub 1 equals, in this case it was 133. And then you have to have a definition. So what did we know? We knew that the current term was equal to the previous term, a sub n minus 1, minus 3. See, the current term is equal to the previous term minus 3. So there are your 2 things for a recursive definition. The initial condition and the recursive formula. How do you know it's a recursive formula? Because look, you've got the current term is equal to the previous term plus something else going on. Okay? So the key that shows it's recursive is that and that. Well, this equals the previous and something else. The current term is something else done to the previous term. That's recursion. And of course, n greater than 1, I just talked about that. You can't have 0 elements and you can't have negative elements. It doesn't exist because we're talking about elements, 1, 2, 3. In a list, it's got tangible things in it. Yes?
So would they give us like a sequence or like a bunch of numbers that are in order and then tell us to find the definition?
And that's where we're headed. So now let's look at how we're going to use this. And we're probably not going to finish, but we'll try. Now, when you look at these bricks, we've got a 1, a 3, and I've already counted them for you. And the third term, so this is a sub 1, a sub 2 is equal to 3, a sub 3 is equal to 6, the fourth element is 10, the fifth element is 15, and the sixth element is 21. So when we look at these, remember, recursion is about looking at the current definition and deciding how does that relate to the previous definition. I'm trying to clean this up a little. Okay, so this is how we do it. We subtract. So let's subtract the current. Let's start at 2 and go 3 minus 1. Right, so what is 3 minus 1? It's 2. Now let's do the next one. What is 6 minus 3? 3. What about the fourth element? 10 minus 6? 4. Let's look at the fifth element. What is 15 minus 10? What about the sixth element? 21 minus 15. So it looks like whatever element we were on ends up being the answer. 1. Oh my goodness, I wrote the wrong. Oh, whoops, I did. Hold on, I'm losing it here. Look at the current element. We start with the second. Okay, So 2 minus 1. So the current element minus the first element was equal to 2. So look at the 2 and 2. The third element, starting there, taking away the previous element, was also equal to 3. The fourth element, taking away the previous element, was 4. The fifth element, taking away the previous element, was 5. And the sixth element, taking away the previous element, was 6. So we can now state this with a pattern, right? We can say the current element, whatever it was, a sub n, so minus the previous element, minus a sub n minus 1, is equal to n. Do you see that? The current element, 2, which was 3, minus the previous element, take away 1, is equal to the element that you're on, 2. So now we have to write this in terms of the a sub n equals, because we've got to get that down to the a sub n equals. So all we have to do is use algebra. So add this to each side, plus a sub n minus 1, plus a sub n minus 1. So when you do that, you get a sub n is equal to n plus a sub n plus. That was supposed to be a plus. No, I'm sorry. Minus. A sub n minus 1. See, we added the opposite. So it doesn't change the fact that that's the previous element. Okay? So we added it to each side. So it's n plus a sub n minus 1. Okay, and I've got that. Here it is. So if they ask you for the definition, what do we need? The first element, and the first element was 1. So you have to say a sub 1 equals 1, because that's what it was. You got to give them the first, and then you have to give them that definition in terms of a sub n. So there it is right there. Those are the two parts to do this. And I know it's time to go. So you will work problems 7, 8, 9, 10, 11, just like this, and then we'll turn them in on Monday, okay? And then we'll move on with the next lesson, which we're still a lesson behind, so it'll be out there tonight. If you want to work ahead on 9-2, you may. All right? So work 7 through 11, and then we'll turn it in. That's all we're going to do on this lesson. Thank you. Have a safe weekend, and wear your seatbelts. Whew. I didn't think I was going to get through that. All right, guys, have a good weekend. Be safe. And this concludes our lesson.